Welcome. Really big turnout, really great to see. Thank you for coming. For those who haven't met me, I'm Mikayla Stokes. I am the host of Hardware Meetup. So can you put up your hand if you've been to a Hardware Meetup before? Oh, I like that. And also some new faces too, which is great to see. So if you haven't been before, we've been running since 2016 and we're all about bringing people together to showcase amazing companies working in different areas of the hardware space. So we couldn't do this event without our amazing sponsors.
Hi everyone, my name's David Stokes. I guess I'm sort of part of the Outset family here. So I base myself here most of my time. And so in terms of Outset, it's a great facility we've got here. We've had companies like LanzaTech and Rocket Lab start here. And we've got a whole range of companies you probably saw as you came in, all those photos up on the wall. So these are people that are basically working in this building and part of the portfolio. So Outset does three things. First of all, there's space to build like workshops, science labs and that sort of thing. The second thing is around venture capital. So if you're in the sort of deep tech space, so deep tech, science, all that sort of stuff, then they've got funding for that. And the last thing they do is community, which is part of what we're doing here today. So those are the three parts we're sort of focused on at Outset. So if you've got any questions, if you're looking for some lab space or anything like that, just let me know.
Loon Digital.
Sweet. Hello, everyone. I'm Benny from Loon Digital. It's an awesome company. I love working for Loon Digital. We specialize in embedded devices, so software and hardware. We love working on innovative products, almost sort of focusing on health and fitness wearable devices. We do a lot of IoT related devices. Like I said, it's an awesome company. We're also looking for a new employee. So if you would like to work for us or learn about the company, please speak to myself or Edith wearing the Loon Digital t-shirt in the back of the room. I love working there. I'm a junior engineer and it's so awesome learning about embedded design, and there's free beer and cake, so good reason.
And next up we have Lounge Jordan.
Evening everyone, I'm Duncan from Lounge Jordan. I'm a partner in the commercial team there. We're a commercial law firm. I know what they say about lawyers. Anyone who's had experience with them usually be charged in 6-minute increments. I promise to keep this just to 60 seconds and a minute and no longer. So I thought what would help the community is really to talk about something we've been advising a lot on recently, which is shareholder disputes. And there's a plural on that. It's come up a lot recently. And the common theme throughout all of that is that there's been no shareholders agreement. And it's been pretty messy, pretty emotional for all involved. We've been part-time counsellors, we've been part-time detectives, we've been part-time mediators. We've had to hand out pretty healthy doses of the law and reality checks to counterparties that we've been dealing with. And I suppose the key thing here is just to say, look, what's going to be helpful for you guys is to start thinking about those hard conversations early and just have them say, what are your different roles in the company? What's everyone contributing, who's doing what, and just make sure that there's a plan for an exit. I'm here with my colleague Josh as well. He can give you a wave, and we're happy to talk to you about any commercial issues that you may encounter. So Duncan and Josh from Lounge Jordan.
And last of all, Blender.
All right, so my name's Ben. I'm an industrial designer. I started Blender almost 20 years ago now. So Blender is a design, development, engineering consultancy. Taking products from super early stage, just kind of market insight, all the way through helping you guys get to production, basically, and doing everything along the way. So, trying, testing, building, CAD, printing, building prototypes, more testing, bit more testing, some engineering, and then, helping that scale and that production as well. So we're a team of 13 at the moment. Designers, engineers, mechatronics engineers, all just kind of spread across, building awesome products.
Welcome, John. Could you tell me a bit about what you do and I guess just your career in general?
Yeah, so thanks for, first of all, thanks a lot for having me. So I currently hold the role as a product manager for a New Zealand company called AoFrio. The name is a hybrid name. The first part of the name, AO, is Te Reo. It means our world. And the second part of the name Frio is Spanish for cold. So the name of the company means Our World of Cold. And we manufacture motors and refrigeration controllers for the global beverage industry. I started my career as an R&D chemist. My first job out of uni was for a company called Aeroqual. I'll talk a little bit about them in a minute. I did R&D research and then product development and then customer support, and then finally found my niche as a product manager for that company. That was a IoT company building air quality monitors. And then more recently, I've joined AoFrio in the beverage industry.
So how exactly do these devices work and how are they made?
Yeah, good question. So first of all, the transition from Aeroqual into AoFrio was a really interesting one. So in the Aeroqual case, where we were making air quality monitors, we made everything in-house. It was a low volume, very high value business. With AoFrio, we're a very high volume business. So I am not a founder. I think I'm the only speaker that isn't a founder. But the company started in 1986, and so the company's been going quite some time. To give you a little bit of an idea of scale, in 2024, we posted an $80 million revenue, and we shipped nearly 700,000 IoT devices. So reasonable scale. We have a team of 150 staff worldwide, but all of the product development, product management, all of the corporate staff are based in Auckland, and all the product evolution happens in Auckland. But we have a manufacturing facility in Southeast Asia. So right now, the product portfolio which I manage, the AoFrio IoT hardware and software. So the product which AoFrio makes, the IoT connected product, is a refrigeration control system, and which goes into all of the commercial refrigeration systems you see around dairies, petrol stations, supermarkets. So whenever you go into the dairy or a supermarket and you see the Coke fridge, that big branded Coke fridge, or indeed the Pepsi fridge, or if you go into a bar and you see a fridge branded Heineken, quite often it's our refrigeration control system which goes into that fridge. So our clients are Coca-Cola, AB InBev, who are a huge brewer, PepsiCo and Heineken. So we don't make the fridges, but we make the refrigeration control systems. And we have round about 3.5 million of our devices worldwide installed in these. Some people call them bottle coolers, other people call them refrigerators. So my job is to think about what kind of information, what kind of data Coke and Pepsi and Heineken are interested in, and try to make sure that the hardware can facilitate that data collection, and to make sure that our software engineers are able to take that huge volume of data that comes in globally, and we can process it in a way that adds some value back to those companies. So this is a little bit of an indication. This slide shows the product range. We do both what you would call actuators, refrigeration controllers, and then we also do refrigeration monitoring, so just measurement. A little bit about my previous role. So this is also, you could classify Aeroqual as an IoT company. We made bespoke air quality monitoring equipment to measure gases like ozone, NO2, particulate, everything that was of interest to human health. So part of my early role in this company was helping to develop the gas sensing equipment, helping to develop the particulate monitor, but again, also thinking more about, once that data is measured by the IoT device, how does it add value to the consumer, to the purchaser? Okay, what's next? So you asked a little bit about my journey and a little bit about my foray into IoT. And as I was putting the slides together, I was kind of thinking a little bit about the different kinds of the different categories of IoT, and thinking about how I experienced them. And it sort of dawned on me that, and this is just my own personal sort of categorization, but I kind of think that IoT can fall into one of two categories. The first category is sort of the situation where an everyday item, or at least an item that started its life as a hardware device, becomes connected. Right, a classic example of this is the connected light bulb, right? Light bulbs have been around for a long time, and suddenly these things become smartified or connected. But a light bulb still has value in and of itself as a hardware device. You also see this with smart rubbish bins, for example. Rubbish bins have been around for a long time, and some innovative people have connected the rubbish bin to the internet to give information to the rubbish collectors to come and pick them up. And so with AoFrio, it's a very similar journey. So we make refrigeration control systems, and we made refrigeration control systems before they became connected. And so the device has value on its own as a hardware device before it even needs to be connected. But there's another category of IoT device for which connectivity is the enabler. So a classic one would be the air trackers, the asset trackers from Apple, and then with the first company I worked with the remote air quality monitoring and also some medtech. These devices are born into the internet, so many of them didn't have a life prior to connectivity. And what I found on my journey is product managing these two different categories, they have a very different way in which they deliver value to the customer, value to the market, and actually how they're priced and what the pricing and the business strategy is like between the two.
Awesome. And I think you mentioned that in the past, like AoFrio used to be kind of like more like functional, like it didn't actually have any IoT involved, right?
Well, that's right. I mean, if I can be permitted to flick all the way back to the initial slide, when we were founded in 1986, we made motors.
Oh, really? Oh, I didn't know that.
So that was the heart of the company back then. Every single refrigeration system has a motor to cool the condenser and a motor to move cold air from the evaporator. So we were in that industry for many, many years, and it became apparent to those of us who were there that there was another way in which we could add value to the same customer, which was to put refrigeration controllers and to replace the existing mechanical thermostats and make them smart. And add data, because it was clear that Coke and Pepsi and all the beverage companies were really struggling in some areas, which I can talk about. But just to kind of close off that last thought, so my role as a product manager is to think about how the customer perceives value from their IoT device. And it's sort of interesting, in that second category where the IoT device, its primary job is to generate data and be connected. From the perspective of the customer, they value the data and the connectivity way more than the hardware. So in the case of the tracker, when somebody buys an asset tracker from Apple, they don't really buy the hardware, they don't care about the hardware so much, but they really care about the connectivity and the data that the hardware can provide. The same is true of an air quality monitor. In actual fact, the hardware is really just a bit of a nuisance often to the customer, because the customer has to install the hardware, they have to protect it, they have to give it power. They really care about the data, right? So from the customer's perspective, the data is the core value. On the other side, where the IoT device has functionality and value independently, it can be a bit of a continuum. So in many cases, when you buy a connected light bulb, for example, there's an interesting question, which is, do you value the light more than the connectivity? Like, where do you lie on that value spectrum? Certainly for a bin, a bin has functionality, right? It holds rubbish, and adding the connectivity is trying to find a little bit more value. And this has been the journey so far with AoFrio, which is primarily we are a hardware company. We make commercial refrigeration control systems, but there's so much more value and so much more data that we can collect, repackage, and sell back to those big beverage companies. But the challenging thing here is that although from the customer's perspective, they may sit anywhere on the spectrum from we value the data to we value the hardware, from the manufacturer's perspective, the cost of the hardware, the cost of manufacturing the hardware per unit is always going to be significantly higher than the cost of generating the data. So there's this underlying cost that the manufacturer has to cover when they sell the product. And this really does drive some interesting strategic decisions around how you package up the entire value proposition. If you have significant faith in your ability to sell the value in the data, it gives you the freedom to adjust and compete on the cost of the hardware, especially if you're in a competitive market, which is where we are. We have a CFO, obviously, and when me as a product person suggested to the chief financial officer that we might want to give away the hardware for free, and then tried to recover that cost with recurring software subscriptions, I was met, with a little bit of a funny look from the CFO. But it's interesting, even in the last couple of years now, we're starting to think about our confidence in our ability to earn back that revenue if we discount the hardware. So this kind of illustrates the journey a little bit, and this is kind of, those of you who are engineers may be interested. So it illustrates both AoFrio's journey in IoT. It also illustrates a little bit the customer's journey as well. So commercial refrigeration systems have been around for obviously decades. And so they started off with mechanical thermostats. So you would just turn a little dial to set the temperature. AoFrio knew this for many, many years. We were only selling motors into this system. And so we really pioneered the idea of putting in an electronic controller which could generate data, and for which that data could be collected en masse and then sent back up to the cloud and reprocessed in order to add value back to the brand, to Coke and to Pepsi and to Heineken.
And that was very ahead of its time at the time, right?
That was very ahead of its time. We were one of the first commercial companies to utilise BLE, which is the Bluetooth Low Energy standard. It was only just a burgeoning standard when we introduced it. And one of the most challenging things, not for me, I wasn't there at the time, but was to try and convince these massive global companies, Coca-Cola, Pepsi, Heineken, that it was worth them spending considerably more money on a connected controller than it was just a basic thermostat, because this industry is incredibly cost sensitive. But fast forward 10 years almost, and we've just released our first cellular connected controller, which is really a testament first to the engineering, because we built the cellular modem and the entire control board obviously from scratch, because we're a high volume, low cost business. And it just shows the willingness and the understanding now of the customers around data value. So we're now in a position where the customers were used to say, why would we even want any data? Why would we spend more money on a Bluetooth enabled controller compared to a thermostat, to can you give us cellular so that we can have the data more often? So what is it they want? What is it now that Coke want, and Pepsi and Heineken and Carlsberg? What is it that we've been able to show them and to deliver to them? Well, really, there's four main categories. One is asset management. So believe it or not, Coke lose coolers all the time. They just lose them. They don't know where they're installed, and so they write off tens to hundreds of thousands of dollars worth of assets a year, which gives an interesting indication as to how we begin to price that service. Obviously, coolers break down, the condenser breaks, the gas runs out, and so we can sell service and maintenance alerts. Energy and sustainability, CO2 footprint is a huge issue now, and we measure energy. So brands like Coke and Pepsi are very, very interested to report on their energy usage. And the most important one, commercial performance. If you're Coke, you want to know if there's Pepsi in the fridge, or if you're Pepsi, you want to know if the retailer's putting the wrong brand in. And there's a whole food safety aspect as well. So this is the final slide. You were going to ask me, what am I pushing towards?
Yes.
So we want to push towards a future, as I mentioned, where the value of the data really, truly exceeds the value of the hardware, so that we are able to lower the price of the hardware and build market share and increase revenue. IoT is a land grab in many cases, which means if you don't get your hardware into the cooler, you've got to wait 8 to 10 years to have another crack at that cooler. IoT has different devices have different time periods, but ours is quite long. And so I guess if I was going to put a question out to the audience is, how do you convince a customer to choose your hardware over a competitor when the customer is only at the beginning of their IoT maturity journey? How do you convince them? How do you begin to convince them the value that connectivity and data can bring?
Awesome. And is there anything the audience can help you with today?
How can you help me? So we have a range of customers, right? I mean, when I talk about Coke, not to get into too much detail, but Coke are really a global network of independently owned bottlers. So, for example, a Coke bottler in Europe, very sophisticated, they have lots of money, they can see the value in connectivity. A Coke bottler in Latin America, for example, less so, they have less money. But we, like any IoT company, you're just hungry to sell your data and your value-added services to customers who are buying your hardware, and so it can be very difficult to sell that when you have to get over that initial hardware cost, right? You have to hit your BOM cost if nothing else. So I'm keen to hear from the audience if anyone else has managed to take a customer on that journey.
Awesome. Thank you very much, John. Sweet. Now we will head into the Q&A. What feature added in the last few years has been most well received by customers?
That's an interesting question, of course. So I'll talk about a feature which is of most interest to the. So if you think about Coke as an operator, they have two major arms. They have a kind of operational arm, and they have a commercial arm. And so up to now, we sell hardware and data to the operational teams, and they're very cost sensitive. They're always being told, cut cost. And so it's a very, very difficult value proposition to try and sell to them. On the opposite side is the commercial team who are told, make money. And so we recently introduced a feature which helped the commercial teams understand how they can measure what's called purity in the cooler. And purity is simply a measure of how much of your competitor's product is ending up in your cooler. So dairy owners are notoriously cheeky, and the Coke fridge is given to them under the proviso that only Coke product, and this happens vice versa between the brands, only Coke product goes into the Coke fridge, and as soon as the Coke rep leaves, they take out half the Coke and replace it with Pepsi. It can happen a lot, and we've developed clever ways of signalling that behaviour to the brand, and most importantly, we're looking to sell that to the commercial teams who have a lot more money to spend than the operational teams who are just trying to save money.
I saw one pop up, but yeah, how does Coke know that there's Pepsi in there?
Well, this is a public forum, and I'm sure this is going on the internet, so we can't really disclose that exact detail, but we have ways.
Does AoFrio have experience with blockchain technology?
No, we don't. It's an interesting question. There's probably a question I would ask as a product manager to the person who posed the question. What problem do they think blockchain would solve? So, it's a really interesting technology. We don't have a significant problem with chain of custody of data, a significant problem. Were we to encounter such a problem, then I think we would entertain blockchain as a potential solution.
How do you detect how many cans or bottles are in the fridge?
How do we detect how many cans? So, all right, so I'll talk a little bit about how this is done. So there's a technology at the moment which is in its infancy, which is imaging technology, right? So if you can put a camera in a cooler, it can take a photo of the shelf. Modern image recognition technology can tell the difference between a Coke can and a Pepsi can, or an empty shelf or a partially full shelf. Again, that's expensive. If you're Coke and you are some of the bigger Coke bottlers could have anything up to 1 million coolers out in the market. So to try and retrofit or to build 1 million cameras and to try and charge the brands for the data transmission and the image processing can be very challenging. There are some other clever ways where we can partner with the bottler to understand things like how much product did you deliver to a particular outlet on a Monday. We can tell them how many times the door's been opened because we have door sensors. So if Coke knows that they only delivered 1 crate of Coke on a Monday and we can see 400 door swings in a week, there's something other than Coke moving through that cooler. So it's an indication of purity.
How do you ensure the security of a device in the field for 10 plus years?
How do we ensure the security of the device for 10 plus years? So if you mean by security, do you mean if people stealing it? I mean, so the security of our device is not really a problem. The security of the cooler itself can be challenging. These things get stolen, believe it or not. So they can get stolen by the dairy owner, they can get stolen by the delivery driver, they can get stolen by a guy in a mask in a hoodie in the middle of the night. So the way that we track location currently is with all of the employees of all of the companies and all the delivery drivers and the storekeepers all have an app on their phone. And that app can see where the cooler is. So we use the BLE device on the phone to detect the location of the cooler, and then we use the GPS on the phone to geolocate the cooler. When a cooler is stolen, interestingly enough, it's usually stolen, but it still finds its way back into the market, into a commercial location, and it still sells Coke. So sure enough, it doesn't take too long for one of our apps to go and find it in its new home, and to send a found notification back to the true owner.
I don't know if you're allowed to say this or not, but like, have authorities been involved over a similar case?
Yeah, I mean, the police rarely get involved in stolen Coke fridges.
Well, like, you can't just show up and take it back, I guess. So.
But I was recently on a trip to South America where our customers have said, we think one of our stolen coolers is in a location nearby. Let's go find it. And we all turned up and we didn't know what was going on. And somebody went into the store and said, hey, where did you get that fridge from? And they said, we bought it on Facebook Marketplace. And so it was sort of innocent, sort of not innocent. And one of the features we have, which adds a bit of value, is that we're able to disable the cooler via BLE from a distance. That turns the cooler off, and then the person who stole it or bought it can no longer use it, and they often call Coke or Pepsi and say, hey, can you just come take your fridge back, please?
How do you get in the room to sell a value add? I am in a similar position, adding sensing to a dumb device.
Yeah, so that's really interesting. So, I mean, this comes down to really fundamental product management questions. It's like, are you trying to sell to the purchasing persona, right? Are you selling to the person who has a budget? Or are you trying to sell to the person who will benefit from your device? One of the biggest challenges we had was to try and, if you like, cross the room from selling to the cost center at our customer's business. So Coke, Heineken, Pepsi, they have a cost center. These are the people who buy hardware and who have to spend money to maintain it. So they are always told, save money, don't spend. And that's a very, very difficult customer to try and sell up to, right? So the biggest advice I can give the questioner here is try and understand how your device will make money for your customer, and then go and make sure that you get to speak to the person whose responsibility it is to earn money. This works in a B2B environment. I'm not sure if this questioner is in a B2C situation, which is a slightly different environment, but in a business-to-business setting, you really want to be in front of the person whose role it is to make money for their company and tell them how your device is going to help them do that.
I'll answer these two last questions quickly. What's the biggest difference you've seen in the development process between your two companies with low and high volume manufacturing?
Wow, that's a fascinating question. Yeah, so in Aeroqual, where we make low volume, very high value air quality monitoring equipment, one of the biggest differences between the two companies is at Aeroqual, and Aeroqual is a private company, so I can't speak too much to the financials, but they enjoyed a reasonably healthy margin and reasonably high price because they were selling into a very high value market. And so as a product manager, and as a product development person, it was fairly easy to say, we need to make this modification to the product, and we have to spend, a few $100s there, a few $1,000s there. And we were very confident that we could get that back from the customer. At AoFrio, one of the most interesting exercises I witnessed was a cost down exercise by the engineers that took 3 to 4 to 5 months to try and shave 50 cents off the BOM cost, because that makes a huge difference to the customer when they're buying the product in volumes of hundreds of thousands. So that was the primary. That's a huge contrast.
Awesome. Thank you very much, John.
All right.
Thank you for joining me, Rob.
Thanks for having us along.
Perfect. So could you tell me a bit about what you do?
Yes, so well, a little bit of backstory. At the moment, we're focusing on smart energy systems. So we have Ecologic, which has been around for a bit longer, developing a energy management system. And we recently have just been the CTO of Local Energy, which is a startup with some interesting business models around solar and battery. But yeah, over the been sort of 20 years doing different aspects of IoT and smart technologies. Started off in super yachts and now into this sort of thing. Yeah, so a little bit of the backstory there. We firstly, Kiwi Tech was back in '95 with mucking around with on the America's Cup boats, managing the race data. So we're collecting all the data from the instrumentation and had a little compact concerto, making it waterproof up on deck there with a long cable, no cableless, and filling the pens up with silicon. Then we tried to commercialise that a little bit into other race boats, but mainly took off in the when we added charting on top of the computer-based systems, and then got bought by Ray Murray. Then set up Sumation with a friend, and we developed a bunch of technologies there. Got acquired by Navman eventually, and then did some setting up systems for aged care, smart home. Led to where we are now, focusing on commercialising in the smart energy space. So yeah, some of the interesting things back then, we had the America's Cup was in New Zealand and there was no TV coverage, and then Virtual Spectator was there with this amazing system that needed good internet back when cellular was 28 point something or other kilobits. So we thought, let's do something about that. So we managed to put a wireless link. We budgeted on putting 20 base stations to get coverage out in the Gulf, and ended up getting away with one. So we had a bunch of money to invest in other things, which was good. But yeah, all of the super yachts and media boats were using the wireless LAN system back then. Then we, at Navman, we created a system with a whole lot of network modules for things like the sounders and the radars, and the world's first touchscreen-based chart plotter, which had radar and sounder and entertainment and all linked up on the internet. And that was an interesting journey. So yeah, right now bringing us up to the Ecologic has been focusing on the smart energy space. So the automation side of things, we sort of connect to a whole bunch of different products and luxury homes and businesses, but this is all about bringing down to a very small set of products doing a key function at volume. So it's a bit of a change. What we're doing there is we're doing a lot of work with the Ministry of Education to where schools are overloaded with energy, and we put in a system to monitor in real time the energy usage and then control the key variable loads. And that way we can avoid the infrastructure costs as well as saving a lot of energy. Because amazingly, there's 70,000 heat pumps in 2,500 schools roughly that are using about, schools themselves, about $100 million worth of power. And interestingly, 40% of that when there's no one there at all. So we reckon we can save 10 to 20 million of that per annum, plus there's a lot of cost in the infrastructure to manage that peak demand, which in the schools is actually quite a very short period of time. So apart from control, batteries is the other way to go. But yeah, I've fairly recently become the CTO of Local Energy, and so we're using the business model here is to put large-scale solar onto roofs that like a big commercial property that have already got really good connectivity to the grid. So the battery can be the solar panels can be installed in a very efficient way, all the right angles and flat big surfaces and stuff. And then we typically sort of target on having about 1 megawatt of solar and say 3 megawatts of battery, so about a 3-to-1 ratio. And then in the houses and associated off the same sort of power outlet, the same grid exit point, we can monitor them, and if we want to, we can be exporting to match that amount of power being used. So Local Energy is the retailer for both the clients and the main site, and the EMS system that we've developed is managing that and controlling the state of discharge of the battery. And really cool project to be involved with.
So that's specifically the Ecologic one is being used to integrate the whole system.
Yeah, that's right. Yeah, so the Ecologic energy management system is used for that, but we're developing some ancillary add-ons for the site evaluation tool and the whole business processes around it as well. And the data sets link back to each other as well. Yeah, so you've probably seen a bit in the news, and we're all experiencing power cost increases. So there's, it's a very broken market, and we're really excited to be able to really do something about it. I think only a portion of these roofs could actually power the country, so great thing to be involved with.
And so how does this all work then?
So there's a lot of different aspects that we could be controlling, but we're really focusing firstly on the key items within those environments. So we use a heat pump controller, which we put our own firmware on at the moment, but we're keen to build our own. And we have a local hub. Of course, when you're managing energy, like the crazy thing is, if you think about it from a roading comparison, you've got a 4-lane motorway or whatever it is into town at the moment. So if you did what we do for power, you would actually you'd build as many lanes as you need to for the busiest day of the year. So you might have a 50-lane highway eventually, right? And 90% of the time it's empty. So we're putting the management in there to avoid that. But then of course you've got to be careful it's got to be reliable, because otherwise you'll trip the breakup type thing. So we've spent a lot of engineering around that so that we can either handle either a hub failure or internet outage failure reliably. But long and short of it is we control the heat pumps, we control the hot water, we manage the energy in real time, sampling the data about every second across all these phases and different aspects. We can create a virtual meter when there's tons of different DBs around the school, and then we can manage control everything from there. The impact of this is this is a school that was tripping out and would have otherwise had to spend $300,000 on the upgrade, as well as a big ongoing cost. I know one school's paying $65,000 a year for a transformer with 5% utilisation. So it's not just the capital cost, it's the ongoing. So this is where we managed to get the curve down quite quickly, and this is the same school this morning, where you can see from 4 a.m. we're starting to use load, but it's a much flatter curve than it would have been if we weren't controlling it. And this energy is generally greener and cheaper and lower carbon and all that stuff too. So with the Local Energy, we've got they've got the main site, and some of the things we're enhancing within that is, obviously we're pulling in the spot price, which is the half-hourly price for electricity, and then we also try to predict that by looking at the weather forecasts and solar and wind and things like that, and that helps the system to manage the charge and discharge of the battery. We're also linking into the demand response system, so that these are mechanisms that are slowly being developed but will mature overseas, that allow the lines companies and the energy retailers to signal to the market that they either want to save energy or to in fact absorb energy, because if you've got a big solar farm and the sun comes over it, it's significant amounts of energy coming up and down these days. So we use a whole bunch of different protocols and technologies for this, but we can use anything from the expensive hardwired KNX systems through to the LoRaWANs and the MBIT cellular-based products. But So in its sort of simplest form here, we measure the load and control the heat pumps from IR or the more expensive internal unit, and by measuring the energy in the hot water, that allows us to be able to prioritise and control without the cost of measuring the actual water temperature. So we go in patterns and machine learning type techniques to help manage that. And of course, the battery side of things. So that's when we, in the main sites there, the system has to also separate out what's the activity from the solar and the battery from the activity from the actual building itself, as well as managing that charge-discharge side of things. Vehicle to grid, very interesting additional perspective on this. We should be able to roll this out in the next few weeks from a testing point of view. But so that's using a DC to DC charger initially, and of course it's quite cool because we can actually capture that solar from the large sites and actually even transport it home, where we can be exporting into the grids there, as well as supporting the local consumption from that property. So very interesting use cases there around financing that and rolling that out. I think a third of Australia, in the statistics I got from Australia, a third of vehicles were V2G that could power the country. So it's can be a significant change.
Awesome. So what's the future shaping up to look like then?
Yeah, well, we're growing quickly, and at the moment some of the things we're focusing on is, very much when you're controlling energy, it's all about making sure that you're not creating inconvenience. So how do you do that? How do you do what a smart person that was focusing on that would do in the background, so that no one notices, no one has a cold shower, no one has a flat EV. How do we do that and allow this to work through as a big part of it? So it's really around the controlling. It's transitioning this into a high volume environment, and then really working on the data sets, and also bringing down the cost of the hardware. Those are some of the key aspects for the rollout that we're doing. We do want to take this into a package that can be easily transportable and applied in other countries. And then, we developed a lot of other interesting tech around the IoT space that that was difficult to get to market, like the aging in place and the some of those technologies there. So we're very keen to continue on the wider journey as well. We built a number of things in the agri-tech market, but the farming community was again not the right timing. So not just what we're doing here, but the IoT, and there's a crossover to a lot of those aspects with things like farms have a big need for the resilience and the backup power, and they also have issues with the grids, end of line on the grid, and so there's some fantastic things we can do there.
Awesome. And is there anything the audience can help you with today?
I guess I think we're very passionate about the opportunities here within the energy space. I mean, you've seen businesses closing down, we've seen people experiencing power poverty. There's billions of dollars that will have to be spent on that infrastructure. So it was great to see this coming, to more of a mainstream, because it's very solvable, and we're really excited about what we can do to contribute to that. So in terms of what we're looking for at the moment, we've rapidly expanding the team. We do feel that there's some great opportunities to create our own hardware. One of the key things there is, when we're in environments like the schools, there's a lot of devices already, so we don't want to be having multiple devices on their network in the classrooms, for example. And there's millions of them to roll out. So incorporating that heat pump control, as well as occupancy detection and CO2 monitoring and that sort of thing. And the other aspect of this is really the communication side of things. So in this case here, we might be using things like LoRaWAN or BLE for the sensors that are within the proximity of the main sensor, and then also rolling out with at the higher volume side of things when you don't have the control over the network. So a couple of hardware products that we're developing there, and lots of software to be developed still.
And you're happy for that to be both in-house or also outsourcing stuff as well?
Yes, that's right. Yeah, on the hardware front, we can absolutely looking for both approaches there. please connect with us. Yeah, we're on local.energy.
Sweet. Thank you very much, Rob. Alrighty, question time. How is this different to super energy?
It's a similar concept to super energy. There's a few different models like this around. One of the things we probably didn't touch on is our ability to shift the load profile of the building. So we're using our technology to change the profile. So if I didn't really touch on that enough earlier. I think the batteries are still quite an expensive way to store energy. So if you think about being able to store the energy in other ways, so into your hot water or into your EV are common scenarios, but actually preheating a room or pre-cooling a room is can have the same effect because you're not then having to use that energy at the peak time. So that's it's an interesting one. Our algorithms try to warm up rooms, for example, and then see how fast they cool, and that way we can see which ones to operate in what order. So yeah, it is another community energy project, but with you've got the technology that we're using to achieve other things here as well.
Are you concerned of security and data risks using third-party foreign hardware from manufacturers such as Tuya?
Very much, which is why we're no longer using their hardware, but we're now flashing that with our firmware. So we're now using direct connection from those devices to us, to our hubs, and we plan to continue that approach. That very much is a product that comes with a 2-year software, in fact, but we can override that, and we want to get them manufactured with our firmware.
Are you working with other NZ power companies like Evnex and Basis?
Yeah, Evnex is not yet doing the V2G, and they don't have their API open, which is sad. I'll keep bringing them up about that. They keep saying, yeah, maybe sometime, but not at the moment, which is a shame. The Basis, that's it's an interesting product for sure, and we would hope that they have a open API or a way that we can work in with it, because measuring things at the it's a great product, and measuring at and controlling at the DB at the distribution board is good, but it is very limited because there's only a small quantity of energy devices that can be controlled effectively from there, namely the hot water. But things like heat pumps, you don't want to be giving them a power cut. You want to be controlling them at the device and having a more granular level of control. A lot of other loads like pools and things are not necessarily on the direct feed back to the DB. So our thing has been behind the meter and throughout the building as a control system, not just at the DB.
Are there any improvements you'd recommend for the country's wider energy infrastructure that would enable future development in this space?
Apart from the regulatory framework, which is rubbish. So there's a lot of problems in the industry which you've seen in the news has been fixed. But I think there's a huge amount of yes. Look, we've got to get away from burning. We're importing millions of tons of Indonesian coal at the moment and burning it. What's that about? There's so many issues around that. Yes. Encouraging this smarter grid and putting in place the infrastructures, being on the forefront of that. I think we've done it in the past, and we have the opportunity to be a leader in the space and to be actually exporting that. We've got a lot of green power already, but we need to be managing that load, managing that properly, so that we can actually use even more of the renewable energy and be a leader in that space, I believe.
What is the most common reason for people not wanting to use your systems?
Well, I think traditionally people have they don't want any complexity. So you want to come home and you plug your EV in, right? You want to turn the tap on and you want the hot water. So I think it's all about making it easy to and there's a context around the energy there, which is making sure that it doesn't create inconvenience is probably the biggest one. But I think the wider context around what we've been doing with our integration of different technologies is to just make it easier. What do you do these days? If you're a consumer, you go into a technology shop and there's this array of technology from different manufacturers, and it's incredibly confusing. And then you end up coming home with 10 different apps, and it's not easy. So integrating that in, making it easy to use, packing it up, making it easy to deploy, those are some of the key barriers, I believe, to success.
How do you deal with privacy when energy consumption can tell you a lot about a household, number of people, when they get up, get home for dinner?
I think this is, again, that's a bit of a wider issue for everything these days, isn't it? I mean, we're getting more and more, and that is the thing. Do you close off, if you like, and be sort of off grid, or by linking into these things, the benefits of that? Sure, I guess it depends who has access to that data is obviously the key thing, and like any other company, we're trying to be absolutely as solid as we can on the security as part of the answer. But the other one, I think, is to, that by enabling these types of things, we've accepted a level of privacy for other benefits, and I think this is an example where it makes a massive difference to the overall infrastructure and our use of fossil fuels and things by allowing the smarter systems to monitor and control what's we're doing, and it shouldn't necessarily be in a way that's personalised. Their data should be abstracted from that, I believe.
How do you integrate with all the different brands and providers for the different pieces of hardware like boilers or heat pumps?
It's a really good question, and that's some of the challenges for moving away from a two-year based product or that sort of thing to where we have to have our own drivers. So I've literally made and then lost and spent millions on developing bespoke hardware and things to try to create that drivers, which is very challenging. So we are leaning a lot more towards open source software, carefully managed, to allow some of those wider drivers of the more, and then bringing in the direct connection to the more mainstream products. But it's a really tricky one, that one. I mean, there is some moves around Matter and things like that, which is more of a unified integration. But a lot of the engineering and challenges is around integrating these different technology protocols for sure. But yeah, at the end of the day, because we come from an automation company, I feel that we can background, we're actually used to dealing with a whole bunch of different things and bringing them together, which is so we've got a really great team around us to help with that challenge.
How are disturbing/distorting loads governed in New Zealand in terms of harmonic allocation?
That is an area where there is a lot of benefit from these types of systems, but it's not an area that I've got a huge amount of knowledge around myself. I know that it's a problem, and I know that by batteries and these types of systems that we're putting in have a benefit of that, but it's not something I have a personal deep knowledge on. Some other members of our team might.
Do your customers care more about energy cost or impact on the environment when consuming power from fossil fuel power generators?
I think the nice thing about where we are now compared to maybe the smart home sort of space or whatever is that generally speaking, people are getting both benefits. So if they're more interested in the CO2, I mean, we literally can have things in our model to provide that option. So, this generally speaking, those two things go hand in hand, I think, is the big thing. We're reducing carbon and we're reducing energy costs and infrastructure costs all at the same time, and creating a much nicer environment. All the teachers, and the main feature we get is that they like coming into a productive, warm environment rather than freezing cold, or home to a nice, cool environment. So there's a nice benefit.
And last question, what are your thoughts on the consequence of local grids reducing the fees that get paid to support grid maintenance and the impact this has on domestic prices?
Reducing the fees, yeah. So, when we're cycling the batteries, we're actually using more fees, but we're lines fees, but less. I think probably the main response that I have to that is that by introducing these smart systems, we can actually reduce the overall infrastructure costs. I mean, one of the problems that's there at the moment is that the lines companies and the EDBs they want to get a return on assets, and the more assets, the more they can kind of justify that. So this is really an important step to actually look at the wider picture and say, do we really need to add more assets, or can we just manage the assets that we've got in a more cost-effective way?
Cool. Thank you very much, Rob.
No worries. Cool.
It's now my favourite time, pitch time.
Hello. I wasn't planning on pitching, but I thought, why not while I'm here? They don't come twice. the opportunities. So firstly, I'm Raquel. I'm at university. I'm in my second to last year of computer science. I found out I enjoy math and I like making software. So first thing I want to talk about is I definitely want to start a company, and I'm currently looking for co-founders. So hopefully, if you are interested in taking that shot, maybe we could talk afterwards and find problems that we think are worth solving. Secondly, I was part of the Center for Innovation and Entrepreneurship, and we had a project go through just before investment. All of our engineers decided that university was more important. So if you can make Internet of Things sensors, that would be useful. And thirdly, if I can help you make software, I would love to. Thank you.
Awesome. Thank you, Raquel.
Hi guys, my name is Talha. I'm a final year computer systems engineering student at UOA currently. I love embedded systems. I love designing stuff all the way from the hardware level up to the firmware level. So this is one of my projects that I've worked on this sem. I'd love to talk to you guys about it. I'm also doing a research project with FPGAs and accelerating AI. And one of my dreams is to make a positive impact on the world by introducing modular and repairable consumer electronics, kind of like what Framework Laptop does. If someone's interested in talking about that, I'd love to talk to you about that. Yeah, thank you. And thanks to Hardware Meetup. Yeah.
Hi, I'm Johan. It's fantastic to be here. My desk used to be just here. And I Mumble years ago worked as the first employee of a startup. And so it's fantastic to be amongst in this ecosystem. Okay, so I worked for Callahan Innovation for 20 plus years. I've done lots of deep tech development. did a stint as team leader of computer vision there. Computer vision, embedded systems, systems integration, that's sort of my home ground. The AI wave, fantastic for computer vision, deep learning for computer vision algorithms, and nowadays AI-assisted engineering, still very much into that. Of course, Callahan doesn't exist anymore, so I'm now out for part-time work, contracting, advising. I've seen it all. If you just need somebody to cast an eye over your future plans and your strategy, I might give you a hand.
Awesome. Thank you very much.
Hello everyone, my name is Louis. I currently working as an automation engineer at a QA firm called Sendify. But I have been working for 3 years, helping customers to build CI/CD pipelines for their software through production. But since my background is an electronic engineer, I want to seeking for opportunity to do some software and hardware mixed engineering job. And I'm very passionate automation. I believe I should use technology to build more efficient system and more to help humanity to have better living quality. And this is my mission. And in my house I have like 56 gadgets to control. I have switch. So this is my passion.
Hello everyone. I'm Ramandeep. I'm an electronics engineer with the education of bachelor's in computer science and master's in VLSI design. I have 9 years of experience in SOC verification, IP verification, FPGA verification, automation, and validation of software, simulation softwares as well at application level as well as a firmware. And I'm here, I recently relocated to New Zealand, just looking for a new opportunity and more interested in good projects in electronics domain. Thank you very much.
Awesome, thank you.
Hi everyone, I'm Zolan. I'm coming from Hungary. I'm a database developer with more than 7 years of experience fixing messy hospital, bank, and other high security systems. But outside of the IT world, I'm a problem solver, a tinkerer. I created a drink tap with Peltier cooling when it was too expensive to rent out beer keg. And I created specific lightings for my specific UV resilient dices when we play role-playing games. I love solving problems. There is a Hungarian saying, building an iron wheel out of wood scraps. I'm that type of guy. I'm in New Zealand on a working holiday visa. I'm trying to find my place because I love it here and I want to stay. Thank you very much.
Thank you. Chris has made a cool thing.
Yeah, so this is just a personal project, so you might have seen it over there before. It's a map of all the trains in Auckland. So it's, yeah, so a whole load of addressable LEDs, RGB LEDs showing different lines. If you're curious, purple's the out-of-service trains, and then the colours are what routes it's on. I'm a train nerd, so like, you know. But this was just a personal project I did. You know, I thought, I'll just make 5 of them. I'll give one to my dad and some of my train nerd friends. Yeah, people kept asking for them, so I've started selling them, and I can't keep up. So it's been a little bit of a busy month, I have to say. Yeah, it runs, there's a server in Australia. This is running an ESP32 chip, if you know where that, which is quite cool. It's the new RISC-V version, so not ARM, not Xtelica. It's quite cool. Also, it took me way too long because I decided, oh, well, it'd be cool if I could like get the chip on there rather than a module and do all the supporting components and put it on a 2-layer circuit board. But easier said than done. But I had a lot of fun with this project, and it's, as of a couple of days ago, it's open source certified. Yeah, come chat with me. Over there.
Chris also has his schematics with him as well, if you'd like to see those too.
Yo, what's up, everyone? My name's Alex. By day, I have a job, but by night, some friends and I are very curious about building a business, and we have an idea, and the idea is we want to give basically better intelligence to supermarkets, and by leveraging the already existing supermarket cameras in the store. And so what that's going to allow us to do is better understand consumer behavior, be able to better understand how certain marketing practices affect their behavior, and give that intelligence to the supermarkets. So really, what I'm looking for is probably someone who can work through the side of like, man, how are we going to take that data that's coming through a visual form, be able to turn that into useful consumer insights, and map some of that customer behavior. So if that sounds intriguing to you, I'll be in the back or around. Thanks.
Awesome. Thank you, Alex. And last of all, Soam here has been doing all the videography today for Hardware Meetup, so I just wanted him to come give a little pitch for helping us out.
Hello everyone, my name is Soam. I run a creative agency called Boost Your Brand, and we do everything from website designs to photos, videos, logos and all that. We've been working a lot with the deep tech startups here in Outset, so if that's anything that you guys are looking for, then I'll be behind the camera. Come talk to me.
Thank you. Now, for our last speaker of the night, I have Baden from ProTag. Thank you for joining us.
Thank you for having me.
So could you tell me about what ProTag does?
Well, ProTag is livestock wearables. So we are all about tracking the behaviour and location of cows, of sheep, of any kind of livestock, and kind of solving the observability problem that farmers are running out of time in the day. The farms are getting bigger, compliance is getting harder. Can we give them that 24/7 observability over their animals that people used to have back in the day? You know, can we bring that back with modern technology, and can we do a really good, helpful job of it? That's kind of what we're all about.
So, yeah, how does this work then? How is it made?
So the core part of what we're building is kind of the AirTag. This is kind of the familiar thing most livestock farmers will know about, and we're packing it full of really, really cool technology. So our current tag is about 30 grams, and inside that we're building direct-to-satellite communications, GPS tracking, real-time integrated behavioural models that work off the motion sensors, kind of like your Fitbit, but on a cow, a lot more robust, a lot more advanced, and yeah, solar powered. That all gets sent off, and then we process that further up in the cloud once we get it there. So there's many facets to the technology that we're building here.
Awesome.
Yeah, so many facets: tag, comms, cloud, app. Obviously, as you've heard multiple times today, the end customer doesn't really care about this. Like, they're technology agnostic, they just want to know that it works. But if it doesn't work, then it's a big problem. So we put a lot of energy into making sure that works. Like currently right now, we're going through and figuring out what is the best standard operating procedure for actually putting the tag in the cow's ear, where to put it, what is the location, what compromises do we have to make to actually get it in the cow's ear and have it retain in the cow's ear. We can keep making it lighter and lighter and lighter, but at the end of the day, location does matter as well. So once we nail that, then we've got comms. The tags can communicate currently via LoRaWAN. We're doing a revision on our technology now that will enable us to use mobile networks and satellite communications from that same 25, 30 gram tag. And then all that behavioral science, all that location information gets plumbed off through that communications channel into the cloud where we process it and then present it to the farmer via our app.
Awesome.
Yeah. Inside, there's a bunch of really fun stuff. I could geek out about this all day. We have accelerometers in there, 3-axis accelerometers, magnetometers. We are tracking the orientation of the tag in real time with just those two. Normally you need a gyroscope, but we do some fun math to make it possible. All that is streamed at the blazing fast rate of 12.5 hertz into a feature extractor, a really complex but the classic trade-off between storage size and speed. We're running this on a 64 megahertz Nordic processor, but we wanted to do a bunch of statistical stuff, like all the way down to kurtosis and skew and all this stuff. So we have a really high-performance feature extraction pipeline that then goes into our classification. So every 15 seconds we know which of these 4 behaviours the animal is actually exhibiting over the last 30 seconds, and we package all that up into histograms and statistical stuff, and then we send that off in its compressed state to the cloud. This is an example of some of the behaviours, and we can kind of see the nighttime rituals of them ruminating, sleeping, and then wake up, they go to the milking shed, then they go back to the paddock, and you can kind of see that behaviour progression throughout the day, and it's really fascinating. The first time we had this working and we were looking at the live stream of behaviours from the cow, and then looking into the paddock and seeing the cow, grazing. It's actually grazing. Like, that was surreal. Like, it's phenomenal, cool stuff. Yeah, and a big part of what we do is the location piece. So we fully believe that location is what places behaviour in context. And by focusing on the location of the animal and the behaviours they're exhibiting there, we can get far better results. So, for example, if we can isolate the behaviours of the animal within the paddock, we can then normalise for the size of the paddock. We can normalise for the crop that's in the field. We can normalise for how many other cows are in that paddock with that cow, and then clean up our data, sanitise that data, so when we run further machine learning processes on it, we can start from a really clean foundation, and that's really exciting for us, and we're already starting to see that manifest in some of our early results. Yeah.
And so what does the journey look like so far?
Great question. I came prepared. So we started from an idea back in 2021. We entered that idea into the Microsoft Imagine Cup in a global engineering competition and won our category, the Land Innovation category. From there, we got picked up by a local New Zealand agri-tech accelerator called Sprout. We went through their accelerator program, and that culminated in some investment backed by them and Galan Innovation. And that basically sustained us for the next 2 years as we took our ideas from the garage. This is me looking ponderously over us dual potting some PCBs that have exposed header pins, which is a terrible idea, but for some reason we thought it was really good. We made 50 of those boards. Not one lasted a day. It was really fun during COVID. But we learnt a lot. We tested that tag on a cow was actually empty. but yeah.
You wouldn't have known that.
Yeah, you wouldn't have known that. But we did a lot of prototype deployment through that process with Sprout, and then with the money that we got, we were actually able to work with the wonderful people at Blender and Loon, who you've already heard from today. So how cool is that? Anyway, the guys at Blender took our really ragtag ideas as recent, electronics graduates and helped us refine that, both from the mechanical perspective and the electronics perspective. Like, I have no doubt that over time we could have got to the same point, me and my co-founder, but we got there in 3 months. We designed, this was in the middle of the chip shortage as well. I don't know if you guys experienced that. We got our first electronics ordered, well, the bulk order of everything, before we'd finished the enclosure design. And the enclosure design was a really fun process, as you can tell. So we basically had to lock things in backwards. We hadn't even got dev boards for things that we were putting in. We just ordered 2,000. We spent like $200,000 on components. We've only just started finishing that backlog of components in our current deployments today. So it's crazy what we had to do back then. But a bit of manufacturing, assembly, test fixtures, ultrasonic welding, don't get me started on that. These tags were a lot better than the first ones. Some of them lasted a day. In fact, one of those tags in that box is actually still on a cow and still working.
Only one.
Yeah. They had a lot of problems. Water problems were a big one, but we can get into that after. But 2023, 2024, we did a lot of trials, put a lot of tags out. If you look really closely, you can see that these are all glued up. A lot of rubberized glue to try to keep the water out. These ones lasted about a week. Behaviors coming in. It doesn't take long to start tracking and looking at the utilization of pasture. I think this was over about 2 weeks of the tags that didn't die. So we've got a lot better stuff now, but it's really cool seeing that first glimpse of insight that we'll be able to pull out of the data. And then that takes us to kind of this year. We've been on a massive revamp of our hardware, going from our first prototypes to smaller, lighter, faster, stronger. In principle, it's still the same electronics, we just shrunk it down. We shrunk the plastics down quite a lot as well, managed to shave off 3 grams, which was worth it. The crazy thing about wearables is if the cow is irritated by something on its ear, it will start flicking its ear. Oh. And then when it's flicking its ear, it gets more irritated. And that doesn't end well. So you end up with a really bad outcome, but the genesis of that was a really small thing. So tiny improvements we've found have massive oversized results. So we are chasing like sub-gram improvements to our BOM because every little bit counts. We're spending so much time looking into the deployment strategies because every little bit counts. And we have our app now, which is amazing. We built this mostly vibe coded. You got to do what you got to do. But we had no app at the start of this year, and now we've got an app, and it's amazing. We're going through refactoring a bunch now, but we are very happy with where it's going. It's supported by some amazing open source technologies, obviously. You can't do anything without standing on the back of giants these days. So thanks to all those people. But this is just a glimpse of the data we can now present. We've got time scrubbers coming, we've got past utilization overlays coming. This is real-time behavior. You can see this cow had a ruminating spike a few days ago when I took this screenshot. And that was because it moved into a different type of pasture on a different side of the farm. And you can see that manifesting directly in the behavior compared to the herd that it used to be in. So really cool data.
Cool. And about like the waterproofing, because I think when we talked, you mentioned that there was like a particular like hole in the device that it was like leaking through. That.
Yeah. I don't know if you can see clearly, but the solar panels that we used, we listened to the supplier on that, and they told us that we needed to expose the solar panels. We didn't need to do that. What happened is that water This is the thing that you only find when you put it out in the field. Water was sitting on that little seam that we put there around the edge of the panel. And then as this was thermally cycling, there was just enough pressure to draw in moisture. And of course, there was no way for it to get out. So that's why all the pictures in the next one, we glued them up. We put a bunch of like shoe glue around that and around the seam, because the other big problem we had was the welding process. This is just magic, but like the worst kind of magic that never works and always backfires. When it works, if you've got a good machine. We don't have a fancy machine, so we spoke to experts on that basically told us, oh yeah, just put a little bit of tape under that corner and that will fix it. I kid you not, that was their solution. It wasn't a solution. What ended up being, or our hypothesis eventually was, our tag at that point was asymmetrical, and it wasn't really symmetrical around the whole weld front. And that, when you understand acoustics, which we didn't, is very bad for the direction of the acoustic energy into the seam. It bounces around asymmetrically within the things. So you have hot spots, you have cold spots. Things don't weld very well, things weld very well and blow out and vaporize plastic. So this is just a fraction of us doing blank welds and trying to rip them apart to understand how the weld interface actually was performing. And that was great until we realized that our design actually bonds, our assembly process bonds the PCB to that front piece, because we've got a solar panel that's exposed, so we need to put like a gasket in there that's 3M adhesed, which then changed the entire acoustic properties of that top piece that we were trying to weld. And then it's a whole lot harder to try pull them apart to see if they're failing, because there's a PCB in the way. So that was annoying. We solved that in the new design by going to this lovely, elegant pie crust format, where the entire weld interface is completely uniform on all sides. And that still has gotchas. If we put the symmetrical top piece around the other way when we weld it, then it will weld differently. But it's symmetrical. Go figure.
So lesson learned is getting it into the field is not easy.
No, there's so many steps that you don't think are steps until they become steps.
Wow.
Yeah.
Cool. And what's the future shaping up to look like?
Yeah, so we've done our prototypes, we're doing our refinements right now, and we're heading towards initial product launch, hopefully later this year, early next, if everything goes to plan. And then following that, we'll be hopefully having the license to go and work on other cool ideas we've got. We know we've got a really good tag for big animals, cattle, cows, what have you, but we know there's also a need for sheep and calves. And we've got this really cool platform now that we could build technology that works with that. Sheep and cows are often in the same paddock, so why don't we build complementary technology that's lighter that could work with our big tags on the cows? Just one of the many ideas.
Awesome. And is there anything the audience can help you with today?
I would love to hire people, but unfortunately we're not financially in that position. But if you do have any insight into the farming system, agriculture, agri-tech, and would be willing to share some of that knowledge with us, that would be really, really valuable. And yeah, if there's any farmers or farm-adjacent people in this room that would be keen to give ProTag a try, I'm keen to talk to you.
Any fundraising at the moment?
Not right now, but we will be starting very soon.
Awesome. Cool. Thank you very much, Baden.
No problem.
Alrighty, question time. Are you edge processing on the tag or expected to send all the data back to the server for processing?
Yeah, I mean, that's a great question. We do a lot of processing in the tag, and that's where a lot of our efforts have been placed. All that real-time motion data is classified directly on device, and that's kind of our method of, sorry David, that's kind of our method for compressing that. There's no point sending raw accelerometer data across a low-power network. That being said, for our current devices, they have a 1 gigabit NAND flash chip in them, and we log everything constantly. So all that data that goes into the machine learning pipeline, all the data that comes out of the feature extractor and all the classifications are all logged for about a month and a half. And then we can pull that off and compare and reprocess it and compare it to new models that we've developed. So that's a really important part.
How does this tag compare to Halter?
Well, it's a tag. Halter's a great product. They've got some incredible cool tech. You could imagine us like the mini Halter, but we play in a different market segment. So we have farmers that have Halter already that are still looking to get us on another one of their herds, on another one of their farms, because the value proposition is so different. We're trying to play in the wearable technology, advanced wearable technology for all farmers space. So it's going to be more of a let's get our bomb down and sell this as a value than let's sell a premium product for a premium price to the top of the farmer spectrum. There are a lot of wearable companies in the world, a lot more than we thought when we started. Halter isn't even the only virtual fencing solution in New Zealand. So there's a lot of competition, and Halter's up here, and all the others are down here, and we're trying to bridge the gap between the affordable technology that can be applied to New Zealand dairy farms en masse, and ideally with our satellite comms to global beef, which hasn't had technology to use because of the connectivity problem. And that's starting to be solved, and we've got some really killer behavioural algorithms which we want to couple with that and unlock that industry.
I like this one. How feasible is it to translate the technology to domestic pets like cats and dogs? When's my dog sleeping?
Actually, very feasible. It's simply, we don't have a remit to go and do the data collection on that. But I was, no kidding, walking my dog today, going, man, it'd be fascinating to know how active this thing is, because it sleeps a lot, you know? But yeah, it's like Fitbits. Fitbits have been around for people for decades. The technology is in its maturity. What we're doing is really taking a different approach to it.
Cool. What is the current and future revenue model? Do you charge for hardware or only for the service?
Great question. This, as has been spoken about a lot, is a big part of delivering a product that is trying to be more than just a retrofit of an existing technology. We want our customers to have confidence in getting the technology, particularly as it's a very early technology. So we're going to go down a leasing arrangement, which is kind of just like a subscription. So they get the hardware for free. It's always kept up to date. It's always replaced. And it always works is the principle. And they pay a monthly or annual fee for the number of devices they have online on cows. And I mean, that's a requirement because, while our hardware is a significant part of the cost, cloud services are also not cheap. And we've got a really interesting kind of balance here that we have a few number of actual customers, but a huge number of actual devices. So we need to figure out how to make the finances work. If I just put everything in an AWS Lambda function, I would run out of money very quickly. So I can't just go and do what AWS wants me to do. I have to figure out how to actually spin up servers and have efficient processing in the cloud that scales with the units and services. We were talking about this the other day with our app. We're wondering how much scalability should we consider for our app development. But the reality is, if we have 100 customers, we're killing it. You know?
Yep.
That's very different to most people building apps.
What made the team keep persevering since you encountered so many technical challenges in the Internet of Cows quest?
Who asked that? Who said there were technical challenges? Oh, I did. It's a really multifaceted question. I can't speak for the rest of the team, but for me, I'm just really stubborn. And I don't understand what the opportunity cost is of not doing it. So we just persevered because I'd love to see this become a reality. Like you think about farming in the future, like currently in Australia, right? Northern Australia, they have massive farms, 250,000 hectares, and they'll put out 2,500 animals onto that farm and see them 6 months later. They've got no idea how many animals they even have. They don't know if they've found the water trough that's next to the water trough they're at, that's 4 kilometres away. They don't know if dingoes and wild dogs are out in that flock. They don't know what's going on. They don't know which cows have birthed which calves or how many calves were even birthed until they bring them back in, and then you're just guessing that some didn't die. There's so much unknown in farming, and I would love to change that. So I'll keep pushing it until either that happens or it doesn't.
I love the perseverance. What are your customers trying to achieve with your product, and how do they measure success?
Great question. In the dairy space, a big driver for, the financial aspect of dairy is keeping cows getting pregnant so that they can keep producing milk. So every year, dairy farmers will go through mating, which is a very stressful time where they are trying to artificially inseminate all their cows. At the average farm in New Zealand is 440 cows. That's a lot of cows. The historical way of doing that is by either tail painting, so putting paint on the backs of cows, and then looking for scratch marks. So cows are the female cattle. They will all get together in what's called sexually active groups when they're on heat and ride each other. That riding behaviour is an indicator for them being on heat. And that's what they're looking for, scratch marks on the backs of cows in that paint. That's obviously a really subjective thing. So as the labour industry in dairy is changing, that skill is dropping, which is a main motivator for adopting technology to safeguard that investment of their herd. Because if you have a really bad reproductive year and you're losing, 10% of your cows don't get on calf, then you're either going to feed 10% of your cows for an entire year and they're not going to make you any money, pay all their vet bills, etc., or you're going to have to cull them. And that's an unfortunate reality of the dairy industry. So if we can provide the tools through estrus detection, through activity monitoring, that will effectively give them the insights. They know when the cows are on heat, and then we're doing them a really great job. That's just one. It changes across the entire industry, dairy, beef, what have you.
I'll leave these last 2 questions. In Europe, cows are used to wearing heavy cowbells. How could you go with more serious gear in markets when they're used to the weight?
That's a great question, and I think it, around the world, the dairy industry is obviously not the same. So fundamentally, dairy in New Zealand is very different to dairy in Europe, where they have those bells. The cowbells in those farms, they are there because they are still kind of farming the old way, where having a bell on an animal makes sense. And I believe, my belief is that those bells were so they can find the animals if they wander off, right? So you can hear the bell. We don't necessarily need that technology. But our approach to wearables is very much flavoured by what farmers are familiar with here in New Zealand, and that's why we went with tags. That's why we've committed to the tag journey and figuring out how to make tags work and putting so much energy into hyper-performant processing and algorithms that run on microcontrollers. Like our that's not the right word, our baseline current with all that machine learning running is 120 microamps constantly. And that's the full machine learning stack running, all the sensors running, all the orientation tracking running, and all the flash logging running in real time, 120 microamps. That's a lot. And that's only, we've only had to, I'm a firm believer, so to get sidetracked, I'm a firm believer in what's called the innovation stack. It's a really fabulous book, if you look it up. It's about the principle of innovating on a stack. So if you're challenged in some way, you're forced to innovate, and that goes onto the stack. And then you're challenged in a different way, and that goes onto the stack. And the principle is that that innovation stack that you end up building up is a defense. because unless a competitor is challenged in exactly the same way, they're not going to be innovating in the same way. They're not going to develop the same stack that will be successful, assuming your stack was successful, right? So the stack of innovation that you establish is the most effective defense. And the book goes into more details and explains why, but that's, I confuse myself.
How does it scale? Sounds like a lot of SIM cards for one tower.
Yeah, well, that's a problem for Spark. They assure me it will be fine. And to be fair, like, there's a lot more people in central CBD than there is on cows on a farm in the Waikato, right? So I'm sure it'll be fine. We use a different mobile technology than the LTE in your phones. It's for IoT, narrowband IoT. That said, our current prototypes use LoRa, and that is a really interesting problem. And one of the reasons we're trying to get away from LoRa, one of the reasons, is that it's not so much limited by range as it is when you have 400 cows all on that same gateway. You actually don't have enough air time to send 15-minute updates. So we have, on one of our 400 herd farms, we have 2 gateways set up and they just share the load. And that's a really annoying scaling problem to have. So I'd rather just have no gateways and use narrowband IoT than worry about scaling that. So yeah.
Cool. I think we'll wrap it up there. Thank you very much, Baden, for your time.
No problem.
That is the end of our Internet of Things event. Thank you so much for coming. A really big thank you to our sponsors tonight. Do you have a slide? Outset, Loon Digital, Londa's Jordan, Blender. So thank you very much.